So it's following that last exercise 32. So let me put exercise 33. So I said something at the very end of the exercise 32, not correct and not necessary. So I put a question that how to show if I know a co-kernel of some morphism is isomorphism, then this morphism itself is 0. Actually, this is quickly because, so say your morphism is T. Suppose you know co-kernel of T is isomorphism. Then in particular, this co-kernel of T composed with T equals 0. Plus the fact co-kernel of T is monic will imply that this T is 0. By definition, monic. Okay, so that's enough to show that small t is 0. When small t is 0, and that's all what we want to prove. We don't care big T is the kernel or not. We don't care. Okay, so in general, we cannot say that co-kernel of A equals co-kernel of B implies A equals B. No, we cannot see. We cannot even see that when A, B are morphism, because co-kernel is just epimorphism. You cannot cancel from the left side. If you know it's moreover monic, you could cancel this monic morphism and say the two morphisms are the same. I'm saying that. So if you got F1, you got F2, and then you got co-kernel F1, co-kernel F2. And if you find actually they are the same, question is F1 necessarily equal to F2. This is not the case. Simply think about if F1 and F2 both are epimorphisms, then their co-kernel would both be isomorphic to 0. Right, but that doesn't tell you F1 equals F2. Okay. Okay. So, and something more, I want to say that, yeah, abelian category epimorphism if and only if the co-kernel is 0, and monomorphic if and only if its kernel is 0. So, first part of the exercise, second part of the exercise. So this could be seen very quickly. Let me just check the epimorphism part. So suppose you have your map from A to B, epimorphism small g, and let's check if this implies its co-kernel is 0. So simply we put 0 map and 0 object. We check the satisfied universal property. Firstly, any small f such that composed with j is 0. We want to show there exists a unique map such that this f factor through 0 map. But this must be the case, and the unique map is 0, because that's the only map from this initial object, 0 object. The reason is because that J is epimorphism, so f composed J is 0 implies f is 0, and so if f is 0, then the unique morphism from 0 to any element, the 0 morphism, indeed makes the diagram commute. So only satisfying the universal property, and so epimorphism implies the co-kernel is 0. Conversely, if you know the co-kernel is 0, can you show that it is epimorphic? So just by definition, if your co-kernel is already known to be 0, then for any f such that f compose G with 0, there exists hence a unique morphism. Make diagram commutes, and that unique morphism must be 0 morphism, and so this is implying that f equals 0 compose with 0, which is 0, and so this proves G is epi. Okay, so we prove this. Similarly, one can prove that it's monic if and only if the kernel is 0.